Okay, let's continue to make the analysis on the complete phase plane for I and current I on the inductor and voltage at capacitor. Here the horizontal axis voltage of capacitor, and here is the vertical axis is a scale I. Okay, not really I, but I times square root of L over C, just to scale it such that an ellipse becomes circle. Okay. We have 4 sequences, 1 up to 4. From the sequence 1, it is a zero order system because there's no differential equation in here, okay? No derivative term. It means voltage and current are constant at this point. Voltage equal to E, current equal to 0, right? And for the sequence 2, it is first order differential equation. If you integrate the current, it's function of time and it's increasing. So current increasing from 0 up to certain value. Then it enter sequence 3. Oh, by the way, voltage is constant and current is increasing. So the line here is just straight up like this. When it enter sequence 3, we have the second order differential equation. I explained earlier that the relationship between voltage and I here is relationship is circle, right? So, it ellipse. If you draw a relationship V and I, but here it's the vertical axis is a scale I. Because of this scale, the ellipse becomes circle like this. And so current can go up and down, oscillate like a sine wave. Yeah, oscillate in the form of sine wave. Voltage also, voltage V, it fall down and then it go up until it reach sequence 4. On the sequence 4, current I equal to 0 again because the switch K is off here. Current is 0, and in this case first order. Then voltage increase because I is constant. If you integrate to find V here, V increase from this value until V equal to E. Okay, then it repeats to sequence 1. Okay, so it repeats like this. So you can have a periodic steady state of the output. Any question? Vandana, any question? No. Say Hui? No. So you understand everything? Well, then next let's do one exercise. Just to warm up your ability to analyze an electrical circuit, especially for power electronics. So in this tutorial 1, there are 2 main parts actually, but the first one is about transistor, about MOSFET, the property of transistor, but it's not the focus of our power electronics, because in our course we assume that all these components are ideal. We can easily switch it on and switch it off, fully on or fully off. But just in case you want to know how it really works and to know how to calculate it precisely, you can go to these 3 links and explore yourself. Okay. And so here the exercise that you are going to try on your own for a moment before I explain step by step what to do. Okay, so first let's try to understand what is this problem about. Actually, this circuit is called magnetic stimulator. Okay. So in this circuit, you have two storage elements, one capacitor and one inductor. So capacitor is charged. Okay, first capacitor is charged. When the capacitor is charged, this one is off. Okay, when it's fully charged, then you switch on to stimulate magnetics. Yeah, this magnetic stimulator may be the device that used to activate your heart when your heart is not functioning, right? So in this problem, we assume that all the switch and diode are ideal. Okay. And so you make an analysis when you start to switch on this one. So this one become closed, and you consider as time equal to 0 at that moment. Okay. And voltage VH pre-charge to capacitor is 950 volt. What is the question? Calculate, okay. Yeah, calculate the following, assuming that the switch S and diode are ideal. So first, you are asked to, this one first. The time response of the coil current after the switch is closed. Coil current means this one. Okay. The time response of the coil current after the switch is closed as a function of pre-charge voltage VH. So you find I here, you are asked to find I equal to a function of VH, okay, and also time. Okay, time response means it's a function of time. And second question, you are asked to calculate the peak coil current if VH equal to this. So you find I max. Okay. And yeah, first you have I in function of time, and then it's easy to find maximum, right? And third, you will need to calculate time t1 at which diode D turn on. Okay. So calculate when this one turn on. From the moment you close the switch until this one turn on. Right? Because first when you close, current flows this way until the charge is not high enough, then the current flow here will suck through this this branch to be like this. And the last question is to calculate energy dissipated in the resistor if the pre-charge voltage is this one. So now try to understand the problems. If you don't understand, you can ask. Then try to solve this problem one by one.